Hey everyone, welcome back to the channel Code with AKJ. Today is day 26 of solving Geeks for Geeks problem of the day. Today's question is circle of strings. So the question says here, given an array ARR of lowercase strings, determine if the strings can be chained together to form a circle. A string x can be chained together with another string y if the last character of x is the same as the first character of y. So if every string of the array can be chained with exactly two strings of the array, one with the first character and second with the last character of the string, it will form a circle. So here, for example, for the array for geek, rig and calf, the answer will be yes as the given strings and can be chained as for rig, geek and calf. So here the problem is simple. Given an array of lowercase strings, we need to determine if the strings can be chained together to form a circle. A string x can be chained with another string y if the last character of first string is matched with the first character of second string. So I have written here the example array ABC, BCD and CDF. According to the question, we need to find or determine a way whether these strings can be arranged in such a way to form a circle. Considering this set of strings, if you try to arrange these strings in a way to form a circle, first we need to compare the last character of first string and the first character of the second string. So here the first string is ABC and second string is BCD, so they are not getting matched, so we'll neglect this. So we'll compare this with the last string ABC and CDF. The last character of first string is getting matched with the first character of second string, so this can be possible, ABC to CDF, and the remaining string is BCD. Since the last string of the CDF is not getting matched with the first character of the last, in this case we cannot create a circle. Coming to the second example, here the strings are AB, BC, CD and DA. So let's try to arrange these strings in a way to find a circle. So here we can see that it forms a circle where the last character of the first string is getting matched with the first character of the second string. Here circle is as shown here, AB and BC, CD and DA, and from A to AB. So in this way, from this set of strings we can determine a circle here. So we'll return 1. In the previous case we can return 0. So the brute force approach here would be to generate all the permutation of this set of strings given in the form of array, and we'll find arrangement where we can compare the last character of the first string and the first character of the second string, and finally we'll determine whether it creates a circle using this set of strings or not, and we'll return the answer in the form of integer, either 1 or 0. So here we'll use the next permutation built-in function where it generates the set of permutation of a given array. Here the array is in the form of set of strings, so it will generate all the possible permutation of this given array, and for every different array we'll try to check this condition whether the last character of the first string is getting matched with the first character of the second string, and return 1 as an output or 0 as an output. And here, since we are generating all the permutations of a given array, the time complexity would be n factorial and space complexity would be O of 1, as we are not using any external data structure here. So let's try to code this approach. So this is code for the brute force approach we have discussed through few examples. Here I have taken the size of an array. I have sorted the array initially so that our permutations get generated according to a lexicographical way. And here I have used do while loop where for every iteration the next permutation function will generate a new array, the new position of the set of strings. I have taken a variable valid which is initially true. I have run a loop from the second index and I have compared the previous string's last character with current string first character. If it is not equal, we will mark the valid as false and we'll break it out from the loop, and we'll check the final condition whether the valid is true and the last strings character is equal to the first string's first character or not. Since we need to form a circle, as condition is mandatory, so to form a circle, we need to check these two conditions and finally we'll return 1. So finally, after all the iterations and checking all the generated permutation of this given array, if we didn't found any circle, we'll return 0 from the main function here. So let's compile and run this. It's working, so let's submit. As you can see, this method of solving this question gives us time limit exceeded. Here the time complexity is O of n factorial, but the expected time complexity is O of n. So we need to find a way to reduce the time complexity here without using any permutation of the given array. So let's try to optimize this approach. So as we have observed, the brute force approach gives us time limit exceeded as we have generated all the permutation which can be very large for the large inputs. So let's try to improve with an optimal solution. So here, instead of generating all the permutation, can we consider these strings as single vertex? Can we consider AC as a single node here? So CD as a single node, C as a single node, and DC as a single node. And in this way, we can use a graph theory here, treat each string as a directed edge from its first character to its last character, check if we can create a cycle or not. So according to the question, the last character should be matched with the first character of the next string. So here, what we can observe from the given set of array is we just need the first character of a given string and the last character of the given string. So string can be here, can be large in the size, but what we need is the first character of it and the last character of it. This goes for all strings in the set of array, and in this way what we can do is need to map this first character and last character of each and every string in the array, and we'll try to create a graph between them. Now after creating a graph, now here we need to check from a particular mapping of first string to what all possible paths we can go here. So from AC we have two possible paths. From AC we can go to CD and we can go to CA as well. So after creating all the edges between these set of strings in the array, so we need to find a path where a particular node from where we are getting started should form a circle by visiting all the other nodes in the particular graph. So here the path here would be from AC to CD, from CD to DC, from DC to CA, and from CA to AC. Here what we can observe is every node is being visited only once here, since to form a circle, and here we are moving through edges. So by observing these two particular condition where the node is being visited only once and we are moving from one to another node to edges, and these edges are visited only once, what we can think of is Eulerian circuit. So as the problem statement suggests, we need to form a circle from this set of strings. As we are converting this set of strings in the form of graph, we need to form a circle in a single component. So if we find a node which is outside of its component, which forms a second component, and it is not being a part of cycle, so in this case we'll return 0. This can be one of the example. From this example, what we can see is there are two possible paths are being generated, which is from AC to CD, CD to DC, DC to CA, and from CA to AC. Here in this case, it forms a cycle. But there's also one path where it does not generate a cycle and it is not covering all the other possible strings. So to summarize the approach we have discussed through that example is that we need to create the edges. How to create the edges? We need to take the strings and we need to take the first character and the last character of each single string in the array, and we need to create a graph out of it, and we need to check whether it forms a Eulerian circuit or not. So here Eulerian circuit should satisfy two conditions. The first condition is each and every node should have equal number of in degree and out degree edges. In degree is number of edges coming inwards to a node, and out degree is number of edges going outside of the node. And second condition is all edges should be visited once, and here this can be implemented with the help of DFS, which also defines whether it is strongly connected component or not. Here, strongly connected component means if every vertex is reachable from every other vertex or not. So, considering the case AC, is AC is reachable from every other vertex or not? So, let's see. From AC we can go to CD. From CD, can we reach to AC or not? So, here from CD we can go to DC. From DC we can go to CA. From CA we can go to AC. So, yes, from this particular node CD we can reach back to AC. In the same way, can we reach CD from CA or not? So let's try to check. So from CA we can go to AC, from AC we can go to CD. So in this way, yes, CD can be reached from node CA, and CD can be reached from node DC. CD can be reached from node AC. So in this way, graph is called as strongly connected component. So there are two possible conditions for a Eulerian circuit. One would be every node should have equal in degree and out degree edges, and the second condition is the graph should have strongly connected components. So let's try to code this approach and let's see whether it gets submitted or not. So this is the code for the approach we have discussed. Here I've taken adjacency list in the form of an ordered map where a character is being mapped with list of character. Here I've taken list of character because a particular node can be mapped with more than one node. In our case here, AC is mapped with CD as well, AC is mapped with C as well. So we need to take the help of list of char or vector of char. So here I've taken two vectors, in degree and out degree. I've iterated over the array. I've taken the size of the first string, retrieved the first character and last character. I've created an edge between them, and parallelly I've updated the out degree and in degree here. You can understand this particular two steps using this diagram. So after creating the edges, our next step was to check the Eulerian circuit exists or not. So the first condition here would be that each and every node should have equal in degree and out degree. This can be easily checked by using a for loop and comparing these two vectors. If at any case they both are not equal, we'll return 0 from here. So the second condition would be to check the graph we created has strongly connected components or not. So for this, we'll take the help of visited vector. We'll call the DFS function where we'll start from the initial string, or we can say initial node. Here I have passed the initial node, which is A, and the DFS call goes like this. Since we are sending the character here, first we'll convert it into an int value, and initially we'll visit this node as 1, and we'll traverse through its neighbor values, and if it is not visited, we'll again call this function. So after giving this DFS call, we'll get all the following information from these two conditions, and finally we'll check through the visited array whether that particular component is being visited or not. Condition ensures that the nodes are in a single component, and if not, it's a separate node which is in different component, and this is not a strongly connected component. This can be explained through this. If a vertex is not visited and it has a in degree value or out degree value, it means we have more than one component and it is not being visited. So hence it is not a strongly connected component and it is not part of a circuit. So we return 0 from here. So if not, we'll return 1 from here. Let's see, try to compile and run whether it gets accepted or not. So it's working, so let's submit. As you can see, the problem got solved successfully. So the time complexity of this approach would be O of n, as we are iterating over the size of an array, and the space complexity here would be O of n, as we are using a extra data structure adjacency list and in degrees, out degrees vectors. So we first explored the brute force approach and then moved on to a more optimal solution using graph theory and the concept of an Eulerian circuit. So I hope you enjoyed the video and learned something new from it. So if you like the content, please don't forget to like, share with your friends, and subscribe to my channel for more coding problem solutions. So until next time, happy coding.